Hey, I'd like to welcome everybody here to our latest hangout here. We're gonna talk about the MVP, kind of go over where we're at with that. It seems like we've kind of been pretty busy, most of us this last couple of weeks. So we're not going to have any new developments, but we can talk. I mean, really big ones. Rob's done some things. Um, he's going to talk about those, and we'll kind of rehash and kind of figure out where we're at, and maybe talk a little bit about um, since we have both Darian here and Rob. I think that we're going to talk about talking mainly about TensorFlow and the Python kind of side of it. The running tests and the data science, the normal traditional data science side of it. So that's probably what we're going to do here. So anyway, so Rob, you were talking about this new meetup here. There's a big data meetup. I mean, not big data, of machine learning meetup.
Yes, and I did send it on our Hangout, New World Hangout groups. If it gets too cluttered with conversations, you can just Google Utah Deep Learning, and you'll come across it. So today is the 11th. So if you're catching this video, maybe a few weeks from now, if you want to check out our Google Hangouts, check out 211, or you can just, like I said, just Google Deep Learning. It just started, I think, just I want to say 2 days ago, maybe today's Saturday. I think it started like on Monday. We haven't actually met yet. I think the meetup is. I'm gonna check my calendar here. I think the meetup is on the it's on 27th on Monday.
So you went to, right? You went to the
yeah, the meetup starts. The first meetup is on the 27th. It's within the meetup group. You can check out where it's at.
So did they talk to you about TensorFlow and all that? They're kind of into all that, like
yeah, right. Yeah, I talked about TensorFlow. I actually brought up to them about CNTK. We're just talking about different technologies that are out there. Pardon me, because they wanted to know how it compared to other, deep learning libraries. So they mentioned that TensorFlow is now available on Windows natively. It used to be that you had to install Docker. So I didn't know that until they told me. So if you want to get TensorFlow to work, you can go to Google's TensorFlow's website. I haven't done it yet. So apparently that all works now.
Cool.
So yeah, I'm talking about CNTK. So probably in our first meetup, we're probably talking about that. The whole group is about learning like neural networks, just how deep learning works in general. So it'd be really good, for us to kind of go there and just kind of learn more about data science and the practical applications for it.
Yeah, that's great to hear. That's probably happening all over the country. People are realizing that deep learning and those networks are kind of getting on board, finding out about it, spreading out more as far as awareness of it. So people are learning about it more. So across the country, that's going to start happening. So I think that it's important that we remember that we want to support that, because people will be coming up with. We want to support those frameworks in the real, because people will be creating all sorts of stuff and coming up with innovative architectures, network architectures, and neural network architectures, and all sorts of things. So you guys are kind of the team to play around with that, and you guys are the guys that we can get we'll do, of course, we'll do the, the integration at some point, but being aware of it and familiar with that ecosystem, I think is really important. For all the stuff that's going on out there.
Oh, and Darren, you're talking about you're learning some of the math. Well, yeah, I know you haven't started yet. I'm sorry. You're gonna try to do it maybe a week or two, whatever. You're gonna maybe try to see. I know you're busy, especially with your kid there.
Well, yeah, but this is important too. So,
well, what I'm trying to say is like I'll try to get. Well, see what their interest is. If they want to get into mathematics of it as well, then I can always come back and tell you and the group what
Yeah. Sure.
So.
Yeah, it's great to be able to. That's one thing that as a programmer, and I think Rob, you'll jive with this, is that you can, as a programmer, you can like put these libraries in, or you can like you kind of get it logically. See the flow of things or whatever, it's a logical thing going on. But a lot of times, these things are black boxes, and you run into problems where conceptually it doesn't do what you're assuming it's going to do, and so there's like a mismatch of like because we don't really understand, and so getting some sort of insight into what's really going on in these black boxes, is really paramount. I think sometimes it's something we run into as programmers a lot.
That makes sense. And surprisingly, I think that delving into those black boxes is kind of one of the reasons I have a hard time getting into programming, is because oh, just use this library, but I feel like I have to know everything about the library.
Yeah.
So I really want to jump into it. that stops me up from actually using it. So
yeah.
But that's okay, because I kind of like to figure out the mechanics and what's going on and the math behind it. So
cool. Well, there's going to be a lot of that with the Python stuff for sure.
So I have speaking of the Python, I have the TNTK tutorial on my computer here. It's not live. It's not like I can try to get into another computer to maybe run it live, but I can at least show you the code and share my screen here. And it's really well documented. We can probably just go from here. So let me see if I can share my screen here. No, are you guys seeing my screen yet?
Yeah.
See, it's a time series.
Yeah.
Okay. So this works with Notebook. The kind of key at its Notebook here is see this N1. So yeah, it just totally works. Now you do have to get CNTK. It's kind of a preference here. You have to get the CNTK source code. And you have to get Anaconda, if I pronounce it right, Python on your computer. You have to get you have to get all that whole thing set up. It takes a little while to get everything together. You have to compile it to work with Python. So if you just get the CNTK binaries, this won't work. You have to get the whole source code and get everything built in your computer first.
Oh, really? Okay. So this is, and you're doing that on
little.
But Anaconda is pretty straightforward. Anaconda
is pretty straightforward, yes. But I'm just saying, you have to get the source code from CNTK installed. Just follow the instructions. I don't have it here in front of me, but you have to get CNTK built on your computer so it can support. So out of the box, CNTK binaries, you won't be able to do this. There's a step to it first.
Okay, so this is really super cool. The reason it's really super cool is because,
Sorry, does that make sense? Should I just?
yeah, it totally does. Yeah.
Okay.
Yeah.
Okay.
Yeah.
So.
Just a sec, let me
Um,
something here. This is really, really important because if you load Anaconda on a Windows machine currently, you cannot use you can't use uh, um, the main machine learning library that's in Anaconda that everybody uses. It's I'm trying to remember the name of it. It's Keras is built on top of it. So the ones that everybody likes, there's a layer. What is it called? I need to find. Let me look it up here really quick.
Okay.
Okay. Here, I'll get my screen back here so you can see while I was talking there.
Yeah. So let's see. It's at Keras. Let's see.
I'm gonna send. Sorry. Well, I'm gonna send this link. I can put it on the Google Hangouts too, so people can.
Yeah.
On their on your computer.
Can people see the links we put up here in the? Is there like a chat that goes with this? I don't know.
I don't know. You might have to put it in the group chat itself.
Hey, we just got an impromptu. Dude here, come in. We're doing a little online thing here. This is James from Storage. So he's a if anybody out there in the crypto world is anybody, they know who Storage is and who James is.
I don't know if I was that.
Oh, well, at least they know who Storage is.
Did I walk into an on-air?
Yes.
Oh, jeez.
So I just wanted to introduce. He's part of the hub here. He's freaking awesome. I feel very honored to have him and here. So I just wanted to say hi.
Thanks.
You're welcome.
I guess I'll get you another.
Okay. Let's see it. Okay, so all right. Anyway, so we were looking at you put the link up there, and let me put a link to Keras as well. Okay, so there's Keras. So Keras is part of the Anaconda package, but the problem is, and it's built on another one as well. And it says it's capable of running on top of TensorFlow or Theano. That's what it was. So the other one is Theano. So Theano is part of the the kind of the base deep learning, and then Keras built on top of that in the Python Anaconda libraries. Well, the problem is that those don't actually work. Those aren't supported on Windows. So you can't get them on Windows. So there's no way to do. I mean, you can. It's like really convoluted, and I was trying to do it the other day, and I haven't finished up that. So supposedly you can, but it's not. Anyway, so what my point is that with using CNTK, which is definitely Windows centric, so you can compile it on Windows using Visual Studio. It's very Windows. It's built Windows first, right, and then Linux. So it's really what Rob is showing you here is very important, because you get access to these really high-end deep learning, and I would even say that currently they're the best out there. I think that what Microsoft is doing is like ahead of the pack, and so we get access to that. Also with GPU acceleration as well. So I think it's very important that I'm a Windows developer, but I mean, Linux is awesome. I like Linux as well. It's just that for me personally, this is great because that gives me the ability to have kind of the same experiences or be able to compete or whatever not always compete, but have the same experiences that Linux, people who are really familiar with Linux get. Anyway, so I just want to throw that in there, Rob. So.
Oh, sure. Yeah. Yeah. Thank you. Yeah, I didn't know that you can. Those libraries wouldn't work on Windows. That's good. Good to have in there. So if you guys can see my screen again, to make sure.
Yep.
Before I continue. Okay. So I can just follow along what it's saying here. It's just this tutorial, just going to show you how to use this with time series data. Shows you how to prepare the time series data for the deep learning algorithms that CNTK has. I just kind of a footnote here too. CNTK supports the feed forward neural network pattern. It also supports the convolution network. It also supports the reoccurring network. It's kind of where you take the output and you put it back into the input of the neural network.
The recurrent, yeah.
Sorry, wait, yeah, they're right. Sorry, thank you. The recurrent. Obviously, it does the evaluation as well when you already have a trained neural network. So it's going to cover how to actually train your neural network, and how to evaluate. Or something I didn't actually look into if this uses the convolution or just uses the recurrent. Didn't catch that part. I just mainly just took this code here and just ran it through Notebook. Just kind of got it eventually to work. Because how flimsy this code is, it kind of breaks at times too. So I'll kind of go over that as well. So just this mocks how to train a neural network, how to predict a stock price. Okay, so we're gonna get some stock values. Those values are gonna come in from the Yahoo Financial. I want to say their website, or I don't know, they have like an API it talks to, but it talks to the Yahoo Finance. From there, you can take a whole years worth of data, and it's going to try to predict what the next value is going to be. I mean, it does kind of give us a footnote here in the beginning, saying that the stock market is extremely noisy and difficult to predict. I just kind of want to preference this. That's done by professionals. It's saying what kind of what it's talking about here. However, I think that our approach is a bit different here because this is just using a single CPU to predict the data. It's only using one data source, using multiple data sources, and it's going to be correct me if I'm wrong, Will, maybe.
No, you're good. That's good. Yeah.
So, in our vision, we're going to have multiple machines running GPUs to do heavy number crunching. Okay, again, using multiple sources of data. So they're kind of preferencing here. Hey, look, if you're just using a single CPU, single computer, they're not saying go ahead and buy stock off these results here. Okay,
Yeah.
our approach is a little bit different. Okay. So, it kind of gets more into details here about what it's actually using. It's going to try to use this thing called the curve fitness bias. You can come back to this website here and kind of do a little bit more reading what it actually does. Basically, it's just a time series data prediction algorithm. It does use this the pandas library in
Anaconda.
yeah, right, for Anaconda. Now I'm gonna talk about, I had some problems getting that to work, but let's look at the code here. if you just run this whole entire code from within Notepad, it'll work. It does. It's going to install Dumpy. It's going to install the CNTK, which you already have to have pre-built and all that source code compiled, ready to run for
Right.
Python. Bill. Bunch of other CNTK libraries it's going to load. Here's the learning part of it. You can come back to this at your leisure too and see everything that's loaded here. It's going to load the pandas. Now this is where you set it to work with just a CPU or with the GPU. Now it'll test your device automatically to see how your system's set up. Compile CNTK. You can tell it during the compilation phase within Visual Studio, by the way. If you want to use the CPU support, you want to have the port. In this test here, we're just running it with a CPU. Okay, so this block of code here kind of checks that. Okay, if you have a CPU or a GPU enabled on your computer.
So, Rob, how that works? That's doing right there. Checking an environment variable on your machine. See if you
Yeah.
want to use. So what you're saying is that you can set it here using this. Like you don't have to use the environment variable. You could just do like do one of those lines, right? And it would work. But you can also set because all it's doing is changing the default. So set it in the when you compile as well on that side.
Yeah.
Change
Right. Yeah. Right. Yeah. You have. Yeah. It's during the whole up phase when you compile a CNTK. But when you compile a CNTK, you have this whole setup thing you got to go through to get the CUDA. Sorry, that's
CUDA.
just an acronym kind of thrown out there.
Yeah, CUDA.
Yeah, right. If anyone doesn't know what CUDA is, you're not gonna know what I'm talking about. You can just go ahead and just start learning about CUDA. Basically, that's the NVIDIA's way of getting your graphics processing unit set up.
Mm-hmm.
Okay. So yeah, I do the whole setup. Like I said, get this down here to work.
Yeah. So
Using GPU.
CPU in CNTK, my experience with it. CPU is easy to get running. The GPU is a little bit harder.
A little bit harder, right?
Yeah, you have to have certain things set up, and you have to have a good device to run it on to get the value out of it. So,
right.
I have the 1080 worked great with the new 8.0, CUDA 8.0, and then you have to add support for just that. So it's a more complicated to do the GPU. So if you're just running tests, like you're just testing things out or trying to get something set up, and you don't want to deal with that or you don't have that set up yet, you can just run CPU and get some. It's just not going to be fast enough to do a lot of stuff, but you can do GPU. You just need to spend some time and figure it out and get it set up. So yeah.
Yep. And it even tells you here, if you want to get it set up here, and kind of talks a little bit more, and and also how many GPUs you want to run too. Okay.
That's setting the GPU, like which.
Yeah. Right.
So in order to get multiple GPUs, it's even more setup. So you have to.
Yeah.
You have to run this thing that Microsoft has for their multi GPU, and it's the same. It's the same thing that you can run it on multiple machines. So not only the GPUs in your machine. So if you have 2 GPUs in your machine, it's the same as if you have. I mean, it's faster, but to do it that way. But it's the same library you have to load and get running. I can't remember what it's called, but it's some Microsoft thing you just download and install, and then you can have GPUs on multiple machines as long as they're networked. It'll send out use all of them.
Yep. Thank you for bringing that up. Yeah, I think this assumes here that it's all on one machine. and this is a array. So 0 really means your first GPU. That's just
You're
talking
picking.
about arrays here. Yeah, talking about arrays here.
Yeah.
So I think it just means that okay, you have one you have one NVIDIA card basically on your computer you want to use.
Not 0.
Right, not 0. This is a
Well, that is 0. 0 is the first video card.
well, yeah, right, but I mean it's an right. It's the first GPU. This is a array, so that's why it says 0.
The index that's the index.
I know if you have GPUs spread across different computers, though, it might be a different code to get that to work. Okay.
Yeah. Yes, it is. In fact, you have to
So this-
write different code for that.
Right.
Right. You have to actually specify that. Yeah.
Yep. So that had to be covered, covered later.
Yeah.
Once we cross that bridge, then we'll figure it out then. Yeah.
I tried it. I did do it. I actually tried it like a little bit. I installed the stuff and I checked it out. So I didn't run it that way because there was an error in it currently at the time I tried it, which was like 4 months ago or something. And so I didn't continue on with it. But yeah. So yeah.
So now this is where the importing the stock data comes in. I had some problems writing this code here. I actually had 2 problems. Okay. When I typed all of this first by hand, like I just did this stuff basically just on my own. I was copying along this code here. I was trying to run it.
Yeah.
Getting this Pandas data reader to download and install didn't work.
Oh.
Okay, it kept on telling me that. Well, it's really weird. First thing it said that it installed, then later it said that it couldn't use it. Like it installed it, but then it couldn't find it.
Huh.
Sorry, I can't run the actual real code here, but it was really just weird. Okay. However, when I ran this Jupyter Notebook example, and I just loaded it. I opened up Notebook, and I actually loaded this file here.
Uh-huh.
You can see my
And ran it.
and ran it. Then it worked. Do not know why. Okay.
You're running it off of GitHub. That's why.
Well, actually, I ran this locally from my computer.
Oh, you didn't run. Right now, it's on GitHub. You ran it.
Ran it on GitHub. Yeah. So when you get the source code for CMTK, it gives you all these examples to put on your computer.
Mhm.
Okay. So I do not. I don't know. Maybe I typed it wrong. I don't know. But when I actually just loaded the thing, when I got to this part, it actually Pandas data reader, and it worked. I don't know. Okay, so just be careful when you try to run this code, and maybe if just try loading the actual example that Microsoft gives you. So okay. Just kind of look at here. Is this where?
Yeah.
So it's going to get the stock data.
So this is an example of a data adapter. Okay, so Pandas, Pandas data format is, and it says that up a little higher, just up in the paragraph high. Okay, Pandas data, up higher in the main in the first paragraph there.
Let me go up to the up here.
Yeah.
Okay.
Yep, it's Panda data frame. So this tutorial introduces how to use Pandas data reader package in Pandas. Please note, this tutorial will utilize the NumPy interface to CMTK, which interfaces well with Panda data frames, a structure that is well suited towards time series analysis. So Panda data frames is the format, the data format that you're importing the data from.
Yes.
From Yahoo Finance into. So when I've talked in the past about in real, what we want to do is we want to import the data from as an example, Yahoo Finance into we've talked about this a lot, into the tensor structure, right? So Panda data frames may be a tensor structure. So it's possible that Panda data frames is a tensor structure.
Okay.
So it may be the same thing, very similar, maybe just packaged differently, but and basically the same data structure. So just as a side note there. So that's what that's doing. That's what that is, and that's what it's doing, and that's how it relates to what we've talked about in the past.
Okay, so we should probably look into a little bit more about this actual data format itself and see exactly if it, what it is that you're describing.
Right. Because eventually, in order for it to run on CNTK and run on the CPU, it has to be a tensor. Like it gets translated into a CUDA tensor, a CUDA tensor.
So you're saying it probably isn't. Okay.
It might be, but it's a good, if they're saying it's well suited, that means it's probably, or works well with, that means it probably is the a tensor itself.
Okay.
So anyway, so go ahead and keep going. I just.
Oh sure. No, you're fine. So this statement here, if it's going to try to install a data reader, if it bottoms out for any reason, it's going to try to, if it can't find it, it's going to try to install it. Here is another thing too. You actually have to have pip installed in your computer for this to work.
Yeah, it should be. That's just a
side note.
Anaconda. It's working Anaconda.
Okay. Now here we go. Now this is where it actually gets into getting the data from Yahoo Finance.
Yeah.
It's just number of tries is gonna try to get it. Right here is meat of it. I've had varying success in getting this to work. Okay.
Yes.
You're gonna see. Yeah, you're gonna see. Let me jump a little bit here, where I'm actually getting. Okay. Next code here, so I'm actually using that. Right here, I'm just defining. Okay. So this here just defines this function, getting the stock data. Okay. Down here is where I'm actually using it. Right here. Okay. So sometimes this part here doesn't work. Okay. Ran this. So up here, this worked pretty much fine. Okay. Especially when I started using my not downloaded. I'm actually ran this from the Microsoft tutorial. When I actually loaded this notebook. Okay, this part worked. This didn't always work. Sometimes it didn't want to get the stock data from Yahoo. Okay. This part of the code did not work % of the time. Okay. I wanted just to say that now, in case we ever going to try to rely upon Yahoo Finance to get our data from. Okay.
Yeah, I mean that's part of making a data adapter.
Okay. I just wanted to preference that now. Okay, so we got it. Don't always expect that when you go and get, especially, it's always going to work. All right.
No, it will.
All right. Well, it didn't. This code didn't always work. Like I had to run it a few times. I actually got data coming back.
It's the same black box problem. It's that you're running other people's code that may or may not have been updated for like changes.
Okay.
In the
okay.
So that's why there's the importance of writing the data adapters for Unreal is important. Because it's an ongoing process. So as those data formats change, you have to adapt to those and keep it updated.
Okay.
But once you do, if you do that and you're on top of it, it will work. Unless, I mean, yeah, especially like a source like Yahoo. So Yahoo Finance is a huge thing that people use all the time, and they are constantly in the business of making sure that their data is available. Not to say that it's not going to be, but if you have a smaller company, it may or may not be as reliable, but maybe it is. So it's a little bit more risky. But and sometimes big companies can screw up too, but that you deal with. That's the whole point of writing a data adapter. Just munging data is programming 101. That's not a big deal. But writing and keeping a data adapter going is a big deal because you're dealing with updating and people changing protocols and network access timing, and there's all sorts of stuff you have to deal with, like to get it so that it's reliably giving you data on a constant basis.
Okay. Yeah, that's something we're gonna have to keep on top of.
Yeah, totally. Yep.
So I don't know what this pickle is. I mean, I didn't Google it yet or anything, but so I don't know what this here is. It's getting some kind of a what?
Well, look and see what it does. You can look at see what it does there. So it's pickle.dump. Okay.
Pickle.dump?
Yeah, do you see it down there?
No.
Pickle.
Where? What? Where?
It says not ospath.isfile.
Yeah.
You see that? Okay, so if it's under the download, it's under download, data file, data equals get stock data, OS path directory name. So it gets the data from your other function. Then it gets the path to the data file. Then if it doesn't exist, it makes the directories so it exists. And if it's not, if the file that's for the directories. If the file doesn't exist, then it's
you mean down here?
File. And pickle.dump, what it does is it takes the data and it formats it. It changes it from regular data into like textual data. So it maybe encodes it some way. So this protocol equals 2 will tell you how it encodes the data, so you can write it out to a file. It's like serialization basically. So pickle is serialization library.
Okay.
Does that make sense?
Yeah, the serialization does.
Yeah, so it's taking the data, serializing it in some way, writing it out to a file, and then the other place you can see it used is read pickle here, pd.readpickle data file, and that gives you the data back out of the file into a data format. So that's what it's for.
Okay.
Down there where it says OS path exists file, and it says print file out exists, data equals pd.readpickle data file. See that?
Yeah, I got highlighted here.
So that'll read the serialized data and put it back into the data structure.
Interesting. Okay.
So all it's doing is saving it. That section, all it's doing is saving the data to a file and reading it back.
So that's if this data file exists. If it doesn't, there's this method here of is test.
Yeah.
Yeah, here we go. Yeah, right up here. Yeah, then it looks like it's going to try to
It's going to make up
build
data.
it, right? Yeah, it's going to make up data. Okay. Okay. So this is the result that it spits out when you run this that part of the code here.
Mm-hmm.
And these tutorials are really cool, by the way. I mean, they gave really good, excellent documentation.
Yeah, that's great. I love
and this is how the code actually, when you run this part of the code here in Notebook, it spits this out. That's what that meant. Okay. So now we're going to building the training parameters. This little description here: the stock market behavior exhibits substantial well, it's a reference here. What that means, I guess. I didn't honestly. I didn't check that part out yet. I'll just try and get this to work. Then we use, well, here's an acronym for it, ETF. If you want, I can.
Exchange traded fund.
Yeah.
Okay.
So autocorrelation exhibits. So the stock market behavior exhibits substantial autocorrelation. So that would be, you could probably tell us about that too, Darren.
Sorry, what was that?
Autocorrelation, like what does that mean? What do you think?
I don't know that one.
Do you want me to reference it now, or should I just continue on? Or
Might as well just take a look at it.
Okay.
Really
there's a
quick.
reference here.
Yeah,
Well, here I'll just click on it. Now let's click on the autocorrelation. It's also known as Serio. Okay. Correlation of a signal delayed copy of itself as a function of delay. Informally, it is the similar. You guys see? I can read this out loud if you guys want me to. It is a similarity between observations as a function of the time lag. The analysis of autocorrelation is a mathematical tool for finding repeating patterns, such as the presence of a period. Okay.
to me, what
So,
that means is
presence.
that easier to predict because time series. So it's a pattern. It exhibits patterns in time, is what it says. So repeating patterns. So if you have, like if you have a sine wave as an example, sine wave is just this. It's a repeating. Over time, it's a very simple autocorrelation. So autocorrelation means, if it means serial correlation, that it just means that this chunk right here of the data is going to be similar to this chunk of the data, on a certain with a certain range. Does that mean? Is that what you think, Darian? Is that what you get from that?
Yeah, pretty much.
Yeah.
Oh, hold on.
Okay.
Oh, sure.
Sorry, go ahead.
Go ahead.
I'm just gonna have to step away for a minute.
Yeah, go ahead, Rob.
Oh yeah. So you have a group such as a periodic signal obscured by noise.
Yeah.
Okay. So where were we here? That's the importing the data. It's a pickle. Okay. Okay. So this is the NTF that encompasses around 500 companies in America stock market. Okay, so we will trade under the assumption that there is some short-term autocorrelation that have predictive power in the market.
So really, what they're saying is that the data itself can be used to predict itself.
Interesting.
That's what they're saying.
Yeah, that's kind of what we're talking about too, right? Because we're looking at time series over years.
Mm-hmm.
Yeah, that's coming up. Okay. Yeah. Okay. So, so whether or not the next data of our given stock will be above or below the current day.
So yeah, that's the goal.
Yeah,
That's
this is our goal, right?
yeah.
Can we
What I've been calling that is the purpose. Like that becomes the purpose. Like the bot would get that. So you'd have prediction as your purpose, I guess, and then the bot's purpose would be whether or not the next data is above or below the current day. So that's what the bot would be predicting. I mean, not predicting, but its purpose. That's what it would try to figure out using the prediction data.
And the predictors, well, actually, the previous 8 days we're looking at.
So it's classifying. if greater than the current.
Yeah. This is right. Here's our predictors. The previous 8 days. The volume changes as a percentage. The percentage change from flux, right? Is what is saying basically in the last 8 days. Well, just like a straight line, basically.
Yeah.
Stock never changed. That's it. Okay.
So that's going to be the output of the predictor. So the output of the predictor is going to predict. It's going to put out. It's going to classify and say. Classification is a binary. So for the first one, previous 8 days, classified if greater than the current day. So it's going to pop out. The predictor is going to pop out a classification saying, I think the new day that's coming up is going to be less or greater than the previous 8 days, and then it's going to come up with the volume change, which is not a binary. It's it's going to predict the volume change, like the amount of volume, which is separate from the price. So it'll predict like that change in volume and as a percentage, and then it'll come up with the percentage change from the previous day. So those are the outputs of those are the three outputs of.
Oh, okay.
I
didn't get that part right then. Yeah. Okay. So. Okay, yeah, basically the opposite of what I was saying. It's not just this isn't how we're trained it. This is what it's going. This is going to be our results of our prediction.
Yeah, and then you use those how much it's off from the reality when it happens.
Okay.
You use those as the training, the backpropagation training. So you actually use those. So it'll predict those three things, and then when they actually happen and it gets the real data, it'll compare the real data to its prediction and backpropagate those. And that's how it does its training.
Okay. This is really important. Next part here. This is a note. We are not feeding the neural network the price itself. Financial time series data are noisy. It is important not to overfit the data. There is a lot we can do here, smoothing, adding more features, etc. But we will keep this tutorial simple and demonstrate CNTK's ability to with time series data.
Yeah.
So help me out here. I thought we were feeding the stock price.
Yeah. So it's for the training or for the input. It's not feeding it the price itself. Like it's feeding it those three things as well. So for the training. So yeah, I don't know. Maybe it is like predictors. Maybe it is feeding it that data and not. You're right. I was wrong. Okay.
Well, this is what we're feeding here. Okay, this gets us to our next point. Okay, so if you run this code here, really, let me just show you. If you run this code here, it spits out this.
Yeah. So
okay.
There's not the price isn't in there. Oh wait, it is open, high, and low.
Yeah. So figure out what exactly is happening here. So we're creating this.
It's listing that out, but it's not. It's listing out open, high, and low, and close, but it's not actually feeding the network that up in here. That's what it's saying.
Okay. Go over this code here and just to see what's happening. So we have this. This is gonna be an array, right? This is what we're essentially declaring here.
Mm-hmm.
And we haven't defined the structure of the array. Just like here's an array, we haven't. Right. Here's our data. That's just our key. This is going to be the value that we're going to be giving it. Now the NP absolute value. This NP.
Yeah, I get it.
If I'm going too fast, stop me. I'm going to screw up here really quick. Where does that NP come from?
NumPy.
Oh, is that like way up here?
You're running your functions.
Okay, so here that comes from NumPy. Okay. Oh, you call it NumPy?
Yeah, NumPy. It's
NumPy,
your
okay.
standard. It's your function library. Your mathematical function library.
Let's
So
call it
that
Num.
you get absolute value. So this is Darian. This is important for you because this is how you do your math. So here's an example. So it's just numpy dot absolute value data close minus data close dot shift one. What is it doing there? It's dividing it by 2. So it's taking the close price and minusing the close price shifted 1, or it's either multiplying. Let's see, plus would be it's shifting it, so it's multiplying it by 2. So and anyway,
I don't know what the shift is.
shift is it's shifting the most likely it's shifting the binary, which means it's either shifting it left or right, which means it's multiplying or dividing by 2.
Oh, okay, got it.
It's
So that's
yeah.
And why are we doing that?
That would be a question for Darian, because why would you? Okay, so if you have data, if you take the data, the closed data, and you subtract the duplicate, the double of it, what does that do? It changes its sign. So if you
Dimitri, I need you to jump down real quick, okay? Okay, let's see here. So we've got data of the close minus the data of the close. Okay, so we're subtracting half.
either subtracting half or we're subtracting double, and I think shift 1 multiplies it by 2. I think shift negative.
Oh, shift minus 1 would shift it, would go the other way.
Yeah, I think would be divided. So it's just a really quick way to multiply it by 2. It's like a super
But
fast
like quick for a computer, you mean?
Yeah. for a computer.
Oh, okay. Divided
So,
by data close dot fill NA 0. Okay.
So 145, if you subtract double that, it's going to be negative 145, right?
Okay. Okay.
Compute price difference is a feature. So it's difference, then you divide it by the actual 145. So negative 145 divided by 145? I don't know why it's doing that.
I couldn't tell you off the top of my head.
Yeah, that's so weird. Okay.
Data close.
Well, it just says compute price difference.
That's-
Really, I mean,
Price
compute
difference. Oh,
price difference.
Oh, I get it. It's not shifting the binary. Shifting is the position. So it's getting close, but it's getting okay. Shift is not. I'm sorry. I thought that was the binary thing. But if you look at it, it's actually a function of the array itself. So shift means that it's shifting the array one position. So it's getting the previous. It's getting the previous data.
Oh, that makes more sense. Okay.
Yeah. So it's subtracting the current data. It's taking the current data, subtracting the previous data, and then dividing by the current data.
Okay. Okay.
Which does what? Like if it, okay, so if you had 145 as the current data, previous data was 100. It would subtract, and you'd have 45. You divide 45 divided by 145, which would give you what?
Hold on. Let me think about this. Okay. So, Sadian, so you got 145.
Yeah. So if you had 145 as your current data and then 100 as your previous data,
Oh,
Yeah.
okay.
you come up with 0.3 would be the answer to that. 0.3.
Okay. So data close. Okay, so it's just. Sorry, go ahead.
Go ahead. No, you go ahead.
No, I'm still thinking through it.
Oh, so basically, it's gonna come up with 0.3. So what it's gonna do is come up with a number between 0 and 1. That is the difference between the ratio or something between the current data and the previous data. So in this case, with 140 and 145 and 100 as the previous data, it's going to come up with 0.31. If it was like,
Oh, okay. So it's just basically turning the price shift into a percentage.
that's it.
Okay.
That's what I said earlier, the percentage. There you go. See, that's why we need you, Darian.
Oh, okay.
So we understand this
So-
stuff. It's turning the price shift into a percentage. Yes. Okay.
So it's just saying it the closed price today was up 30% or down 30%. It's okay.
Yeah. Okay. Okay. That's
Okay. So what's this fill NA?
So fill NA means that it's going to fill an NA, like a number. So if you divide by 0, you get not a number.
Oh, in
You
case it
divide
blows
by
up.
0. Is that possible?
In case it blows up, crashing the code.
Yeah. If you divide by 0, does things blow up? Do things blow up?
Okay.
Darian, I'm asking you.
Oh yeah, if you divide by 0, yeah, it causes problems.
Well, could you ever have like a 0 stock price?
Yeah, of course.
Good.
Yeah.
Yeah. Yeah, if a company goes out of business, if their
Yeah.
stock hits 0, then yeah, they're done for.
So fill NA means that it's gonna take, if you get an NA, which means not a number, right? NA means not a number. So it's
Oh, okay. So then does that 0, is that what it replaces it with?
Yes.
So dot fill in a. Okay, so it says if this is a non-number answer, we're just gonna make it a 0.
yes.
Okay, cool.
Okay. Value, and we're just appending it to the predictor name array.
Yeah, which means that it's just saying that there's a data called diff. There's a data index called diff, and it's just so you know what the name of it is. So that's the diff. And then you have the VDiff, which is the volume diff, which does the same thing with volume as a percentage. So it's grabbing the percentage there. So is this daunting to you, Darian, all this stuff?
The main daunting thing is trying to do it while I'm got a 2-year-old in the background and an infant on the lap. So, if my brain was more like a GPU, I'm sure I could do it all. But
You're only running on CPU mode right now, right?
yeah.
That's all you got left. You're running on CPU. At least you got me.
So I mean, please hold me up. I mean, I know, what anybody really. Please hold me up if want me to explain anything or something to understand, or maybe I'm just babbling around. Who knows? But
No, you're good. And so the parts I
Okay.
missed, I'm just gonna watch the replay later. So
Okay.
okay,
okay.
all right. So now we're gonna go back this 8 days here. So compute the stock or down over compared to the current day closing price. So we're going back 8 days. Going backwards to find it here. So we have a for statement, a for I2 statement. Just kind of just building up this data array here with looks like from the stock from the last, where does it say 8 days though? I mean, I understand this day is here.
Yeah, I get this whole thing. So it's pretty straightforward. It's different than I thought. I thought they were going back 8 days, and if any of the 8 days behind were above, it would like be 1. If it was, or it'd be 0.
Oh, okay. So where the data is greater than basically,
The previous data.
the previous data. Yeah. Okay. All right. Okay.
But it's different because it's different than what I was thinking. It's actually eight different inputs. So if you see on the list over here, it's P_1, P_2. So that's saying on this day, on the 8th day, on the current day, it was 0, meaning the day before that was lower than it is today, right?
Oh yeah, and that's what the 0 and 1 up here is, by the way.
Yeah.
If it's,
Wait. Okay. If
Yeah.
the day is
oh yeah,
greater-
yeah.
If today is greater than the previous day, do a 1.
Yeah.
So if it's 0, it means today was not greater than the previous day. It's lower today.
Uh-huh.
So 1 means it's
Uh-huh.
higher today than it
Yep.
was yesterday. That 0 means it was lower today than it was yesterday. And
Yep.
that's what that, for the last 8 days, it does it for every day for the last 8 days.
So that's what the 0, 1 in here is about.
Yeah.
Hence the zeros and ones and on here. So scroll it over a bit. So if you run this code, you essentially get this graph here. If all goes well.
Mhm.
You want to save data to your local drive is what. So yeah, so I'll spit out this graph and I'll save it to.
The data dot here.
Although I don't know where does it say it's writing data to? That's a comment. I don't want to get too hung up in little details like this, but somewhere in there it does
What are you
save it to
talking about?
your. Oh, that's if you want to. If you want to save to your local hard drive, just uncomment out this line here. That's what it is.
Yeah.
Yeah. Okay.
Data dot head.
And then it's
top
then
10.
we're gonna spit out the top 10 from our data that we're collecting here. Okay, got it. So this data is what we're actually seeing here.
Mhm.
The top 10. Okay. So what are we trying to predict? Trying to predict whether or not the day's trading will be above or below the current day. We will represent a update as 1, else 0 if next day is the same or below. Okay. Note the market is unlikely to close at the same price as it did the previous day, meaning the stock is going to be exactly the same price, and the ends are going to change. Actually, Trump goes on television and says something about some stock, does something bad about some company. Usually that company takes a nosedive. So, which is something that we should probably put in as our data stream. Okay, what politicians, not just Trump, but they're saying what kind of news is happening,
Oh, I agree.
Yeah.
I think
That's the whole.
I've noticed that like news from China and Europe and everything is one of the main drivers of Bitcoin price, at least in the short term.
Yeah,
Well,
that's
yeah.
the point of what we're doing here. I mean, that's,
Yeah.
that's
Yep. So we should have some kind of feed that monitors, I don't know, the weather. I don't know. Well, I mean, there's certain kind of stocks. I mean, maybe I'm just thinking out loud. Don't
Yeah.
maybe the company that sells salt. There's a big weather event in the East Coast, whatever. Maybe that company will do better at their sales. They're selling, but I'm just thinking out loud. No.
Yeah, so you're
Yeah.
at the prediction part, but the prediction part is based upon what you've put in. As you can see, you put in the data. You didn't put the price data in, but you put in the data of whether the day was higher than it was the last day. Okay, so so you've cut out a lot of the noise. So you're telling it like all it's predicting is like whether it's going to be higher or lower today. So anyway, so that's what it's doing here. So it's just using the data that you gave it, which was from that table above there, to do this prediction. So adding in data streams and adding things in is just a matter of adding data to the network. And so it uses that and figures out what it needs. But it's a little more complicated than just, you get that exponential problem if you try to do it all. Just like if you were to try to feed all these things into one machine, it's going to be a problem for it to like search through that stuff and find anything, find the relevant triggers, and know what and learn the patterns of that kind of data stream. This is really simplified. It makes it easier for the network to learn and learn something. The simpler the data is, so you can run something locally on your machine. That's why this 1-0, which being the most simple data format there is, can especially that it's talking about like just the previous day up and forward. So what you're spitting out, like higher or lower, and you're spitting out that out of your prediction here. So let's go through this and so we understand like what it's doing for this prediction.
Yeah. So start first line here. So the data, the key the next day.
Mm-hmm.
That's where we're defining this as. Now here it's a little bit tricky to talk about. So we're now the shift -1. Can someone?
It's the previous data. Or the previous date.
Is that what that means? Okay.
So
It's greater than
previous date
Okay, it's greater than the close,
on the current day.
the current day, right? So it'll be 1 or 0, right? So if it's going to be higher, if this is higher, it's going to be 1. If it's lower, it's going to be 0.
So this is not the prediction.
No, I think we're getting there. I want to go over this step by step.
Yeah.
Then the next day, opposite. What does that mean? Next day opposite.
So it's just okay. So it's just putting this information into the data structure. So it's saying the next day it's just putting this in. So NP where NumPy where it's just saying if it's true it does 0, if it's false it does 1. So data next day equals 1. So it's saying does it equal 1? If it equals 1, then it sets it to 0. So it's just flipping it. So next day opposite just means it's flipping the next day. The one you just figured out. So it's just the opposite of
just so you know, this isn't going to take this is not like a 2-step process or a 2-line process. There's a whole series of things we're going to be going through.
Yeah.
So just don't.
This is just setting it up.
Yeah, we're sending data up. So it says here, we gotta wait until we get down to the very end. It's here. So here's our training data. We're doing it from 2000, so like January, and until that's from 2008, so the last 8 years. Okay. And this is our test data. Now, you guys, the training and test data. So the training is when you actually, so you have your black box neural networks. You want to start your training. Well, here's your training data. Okay. Now you want to see how well your network was actually trained. I'm actually going to test it out before we to production, before we can say yes, our network is actually trained correctly.
So the idea there is that you have this data that's historical, and you act as if though it's real time. So like if you're getting it as it comes out of as it happens. So if you're getting it as it happens, you would be like, okay, this is the current information, and then amount of time later I get the new information. Now it's a new day, and I'm comparing it with the old day. So you emulate that in that process in this historical data in a file that you already have. And so basically you go through it, start at the very beginning. You say, oh, it's 2000, 8, 1, 2, right? Like January 2nd. So I know the data there, but I'm going to imagine or pretend that that is the current day, that I'm actually at that day, and I'm going to try to predict what's going to happen in January 3rd, right, of 2008. And then, so what it's doing here, it already knows the answer. Like the next day, it knows the answer to that. It knows it, but it's not going to let itself know. Like it's there, the information is actually there, but it needs to not trick itself, but it needs to just act as if it doesn't know that. So it's putting in the next day information right here because it knows it, but you wouldn't do this with real data because you wouldn't know the new information yet until it actually happens. Right, you get it.
So what we're doing here, we're training here from the stock prices from 2000 until 2008.
Yeah.
Now our test data has to be different than from what the train, because of course it's going to know what it's been trained against, right?
Yeah.
So now the data is going to have to be different than the training data.
Right.
So to actually test it out, we're going to go from 2008 till 2016.
Right.
We're going to basically see just how well things, like how well did it do. If the great, fine, that we're all happy and satisfied, we can, now we can start doing what we want to do, or we can say, oh no, our test data just blew up, whatever, it didn't work. Now we have to go back and retrain our data. I'm sorry, retrain our network with maybe different. So what, Darian? Does that make?
Yeah, it does.
Yeah. Okay. That's crucial for us because if we, we're gonna release our, neural out to the world, we all make sure that we're comfortable that we think things are trained properly. We test against our data. And I think we're ready to go.
Yeah.
In actuality,
so-
what you really want to do is you want to constantly. So for what we're doing, you want to be constantly, because it's live data. So this is just a pre thing that you can do if you want. But the reality is that learning from real data, like live data, is much better. Like for constantly being able to respond and learn new things, and you're not like stuck, in your. It's like never learning something. It's like learning how to do, something that then disappears, and it makes no sense to do that anymore. So anyway, so this is a lot of this stuff is programming stuff that's pretty hard to like. If you don't know programming, it's really well. It's hard to go through stuff like this. Like for me, it's like super easy. Like I didn't. Like a lot less time than we're going through. I could go through this and figure this all out like really quickly.
Well, I was going to say we're already like an hour and a half into this, so you can see how much more there is to go.
Yeah.
Yeah.
So, right now.
So if you don't know programming, you're going to be kind of battling against that the whole time. Like you're going to be trying to understand, like we just did, what these actual things mean, what they do. But when you do that, you are learning programming. You're learning how to do the same types of things you would with mathematics or whatever, writing equations out in like a computer environment. And so, doing that in Python is what a lot of data scientists do. They figure that out. They learn how to do that. There's other languages. There's R, and there's some other types. But a lot of people these days are going to Python. So a lot of data scientists. So that's just a process you're gonna have to go through. Like it's great to have me, as a guide for that, because I'm I get this stuff like I just boom, I can just through it. So if you have questions on something, what does this mean? I don't get this. It's not making sense to me. Just ping me on the reel, and I can tell you like really quickly, and I'll totally do that. So use me as a say, hey, I don't get this line, and paste it in there, or like paste a link to it. And tell me what it is, and I'll look at it and say, hey, this means this. If you run into something, So I'll totally I totally want to do that. So yeah, we're kind of running out of time here. We can continue that on, you guys. If we want, we could keep going through this because this is a really good introduction to that, and it'll help you, Darian, specifically, and obviously Rob, you're kind of doing it already, and you too could go through that as well because you have a pretty good grasp of it, Rob, and you can help Darian out directly if he has
Oh yeah.
before it comes to me. You know what I mean?
Yeah, Darian. Yeah, please let me know.
Sure.
Well, should I just continue on here? We're already like an hour and a half into this.
Yeah,
we got like a good hour, I think, really to go.
Yeah. Let's. This is good. Let's quit for now. And
Okay.
Like I said, if for the next meeting we do next Saturday, we could continue if you haven't already been through it. But I would suggest just going through it. And anybody online that's watching or watches. Just pull this up themselves and they can set it up, and this would be a good exercise, and you get kind of a start on that process, just by watching this video. So and
As far as getting this thing set up, though, sorry, well, I gotta interject here for a second.
Yeah.
It'll take. It's not a straightforward process.
Yeah, I can imagine.
Getting this thing set up, okay? So
probably the biggest
please contact me. I'm gonna reinstall this again, my different computer.
Mhm.
So please contact me. You're gonna need the source code for this. You're gonna need to install Anaconda Python. A bunch of other things you gotta get set up to. So I struggle with it. So
Yeah, maybe do like a little. You can always do like a little guide yourself, like of what you ran into and the kind of things you had to do, stuff like that. That might be a good exercise too.
Okay.
So, all right. So, anything else? We want to touch anything really quick before we take off?
I think I'm good. The only thing I may have some conflicts for the next 3 weeks. I'm gonna try really hard to come. I may be downtown, so it may even work out to where I could just come to the Impact Hub.
Oh, cool.
But more than likely, it will just keep me from being able to participate at all. So, just heads up on my end. But yeah, that's all I've got.
Well, no worries. So cool. All right. So hopefully you can. Well, I'll see you down here. So it's good to hang out with you.
Yeah.
All right. So let's go ahead and close this up, I guess. Rob, did you have anything else to say finalize or?
Oh no, I just said contact me and I'll put together some kind of we're trying to get this installed. If you have any questions, contact me and I'll put together some like quick notes of things I've done and problems I had and
Cool. You can put it on in a real
where I would
Google Drive. Just make a document.
yeah, okay, and I'll put the link up on the
Yeah.
Hangout.
That way we can all modify it too. So if somebody else finds something, we can modify it and add our own stuff to it too. So if we figured out something or whatever. So.
Okay.
All right. Sounds good. All right. Well, everybody. Well, thanks for coming again to our little geeky hangout here, and we will hopefully see you next time.
Okay. Bye now.
Bye.